This is the GUI of ScorePlus, and when you invoke that, you will see a canvas like this. And you can see you can build all kind of nodes from the choice here, using the drag and using the draw line tool to draw the topology of the power network and the communication network. And for example, it's something. Let's bring out an example I have previously set up. It's a software simulator setup. Here we can see 6 houses, and when we simply click the run here, the system will begin to run. And this is a typical microgrid topology, and you can see all the this is the appliance, this is wind turbine, solar panel, all the members are the generated power flows, and each of them is a lightweighted virtual machine. So you double click them and you will see a terminal here, so you can see all the processes running inside using this command. This is a lightweighted virtual machine, and all the code are actually C code or Python code. It's actually a same process to be run in actual Linux system. And this is the software emulator. Another thing, that part is the hardware testbed. This is a similar setup for the hardware testbed. You see all those nodes are corresponded with one hardware code node, which is those. So this is the overview of the hardware testbed. So you can see we use the solar panel and the lamp to generate the power to emulate at the solar panel, and this is the fan we use to generate wind turbine. And all the black boxes are the entities within smart grid, which represent storage, switch, demander, supplier. So for example, like this one, this is the power supplier, so it can generate the current like up to 200 milliamp. And this is like the power switch. You can see those ports as the connection, so we can write program to specify the connection status between those ports. And here is the like the storage. This one is tell me how much energy is consumed now, and this one is how much energy is generated now. And those are the demanders we will use. Okay, this is the hardware testbed setup for the 6 nodes. So right now we have 1 supplier, 2 switches, 2 demander, and this is the terminal we are going to use to connect to the software emulator in the future. So right now we have run it, so we can see that by the current we can see the real-time power flow reflected on this line. So this is the same number as we can see in the LCD display over there. So this is the corresponding demander, and this is the topology switch, and those 2 are the demander energy consumption we have seen. So so here it is very similar. So if we want to navigate to one of the nodes, we also just double click, and we can see that a terminal can be popped up like the previous one in the software emulator. Yeah, here it goes. So here we can see the terminal over there, and this is actually the BeagleBone. You can see this is the BeagleBone number 2, which is the corresponding node over there, and this is all the BeagleBone processes we have been running. So this is the hardware testbed, and so this is the hardware testbed we have set up. Now we will go over how to connect hardware testbed with software emulator. So over here we can see the connection has already built up, but right now it's not connected. So there's the power flow is 0, and this is remote IP address for the GRE terminal over there. And correspondingly on this machine, I'll set up the hardware testbed cases. And here, this is the remote IP, and correspondingly we have a terminal. This is 2 hardware testbed, so this guy will talk to the other side. So first we will launch this guy independently, and this is still the independent case. So we have not connected the guys each other yet. So here we connect, bring up the dialog and specify the interface information. Then make a request. So here is a request send. On this side, you can see a request is reflected. So we confirm the connection, and then you see after connected here we will see the connected, like the power flow from each side. And here we have the joint emulation is okay, so it starts. So you can see this is the joint power flow will be sent from the software emulator to the hardware testbed. And correspondingly, we can see that the corresponding interfacing part is using this interface module, basically to provide the current, real-time current to the system to do the specification.